Anthony Bear is the flat earther who tried to tell us that the River Nile would not work on a globe because either end of the river would be suspended above Earth. Yes, really. Well, he's got a new video where he thinks that the seasons prove reality, and it is just as beautiful. Hello all and welcome along to this Thursday edition of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Yes, we're 4 days into the 500k subscriber celebration week, and as I said at the start, we're going to look today at the wonderfully innocent Anthony Bear. I say innocent because he doesn't even know what he's saying and you just can't be mad at him. But we're going to debunk him all the same. He's talking about seasons and why they don't work on the globe, apparently. Away you go, Anthony.
Okay, let's talk about seasons on a globe. Now, we were taught this like when we were kids, right? So let's take a better look at it. Okay, here's our miniature globe model, and I'm going to show you how the seasons work. So this is our summertime where the globe is tilted towards the sun for the summer solstice. And we're going to be talking about Michigan, because Michigan's a nice moderate spot to use to show what we're trying to show you. So now the Earth spins for days. That's how you get your day and night. And then at 3 months later, which would be about here, this is the equinox, so it's going to start getting colder because the angle is changing. And 3 months later, which would be 6 months later from the summer, now the Michigan's tipped away from the sun, and that's how you get wintertime.
For a flat earther, that was a very succinct explanation of the seasons. Well done, Anthony. I suspect you're not finished, though.
Okay, in this video, we're going to be talking about Michigan. And if it's possible, the angle of the Earth is going to make that type of difference in temperature from the winter to summer. Okay, so here's Michigan right here. Now you can see it's tilted. This is summer solstice. It's tilted towards the sun. And Michigan hangs over the equator like, let's say 1,000 miles roughly.
Try 2,800 miles, but nice try.
Now in the wintertime, we're going to flip it around the other way. Okay, now Michigan is going to be right here, basically. It's going to be, let's say, 3,000 miles in. So there's a difference of like 4,000 miles between winter and summer as far as the distance of the sun goes.
Oh no. Oh no. He's not, is he? I see what he meant now by the 1,000 miles, by the way. He meant 1,000 miles closer to the sun than the equator. I mean, it's not that much, but that's what he's inferring. And in the winter, he's saying that Michigan is 3,000 miles further away from the sun than the equator. No prizes for guessing what he says next.
Now let's look at the distance to the sun. The sun is 93 million miles away, and at a 4,000 mile difference, take 4,000 divided by 93 million, and you get 0.00004, which is really, heat-wise, I imagine it would be negligible.
Well, yes, it would be. But let's remember that the Earth is actually closer to the sun in the Northern Hemisphere winter, only 91.4 million miles away. And in the Northern Hemisphere summer, it's 94.5 million miles away. The 93 million is sort of an average. So your 4,000 miles there is absolutely nothing compared to the swing of a few million miles every 6 months. And by your logic then, the winter in the Northern Hemisphere should be hotter than the summer in the Northern Hemisphere. But it's not, is it? In Michigan, in the winter, the sun strikes the surface of the Earth at an angle of around 24 degrees. And in the Michigan summer, it's more like 72 degrees. And of course, I'm not talking temperature there, I'm talking angle of the sun. So that means that the same amount of energy is dispersed over a larger area, meaning the temperature cannot get as high in the winter as it can in the summer.
Okay, let's tilt the globe away from the sun. Now, one of the ways we can get an idea is let's say we'll take the coldest day in the wintertime at noon, and then we're going to compare it to, move this back to summertime. We're going to compare it to morning. Here's Michigan. We're going to compare that to morning in the summertime and see what the temperature difference is to see if our angle makes a difference or not. Here's our sun winter sun shining on the globe in the wintertime model versus summertime.
Very much to scale, Anthony. Well done.
Okay, so here is, I'm going to use a stick right here. I don't know if you can see it. Like there's a middle of Michigan. We're doing Michigan because it's out of 40s. It's at like the 44th parallel. So here's our stick, measuring stick. And let's see what the temperature is. First, let's touch the 75 degrees at 522. 91. 90.
Oh no, I'm getting Mikey Smith vibes.
So we got 124.
I don't know how well you can see this, but I made a little protractor. Probably see it better. I made a little protractor to line it up with a string to the center of the heat lamp. So when we do summertime, we're going to try to do the same thing. Oh, doesn't come out that good on. There you go. See?
Oh, bless him, he's trying, isn't he?
Okay, let's switch it around to summertime. Get up. Now we got it facing towards the globe, towards the sun. And let's check our temperature when you get it set up. Okay, summertime. Let's check our angle over here. So you get the idea. I did it better in real versus on the camera.
Okay, so he set up Michigan in the morning where the angle of the sun is roughly the same as the angle of the sun as it is in midwinter. Okay, I think we've got you here so far, Anthony.
And then the length, here to here, it's basically the same. Okay, it's a half hour later. The temperature went up 0.2 degrees in the room. I don't think that's a big deal. So let's see where we're at right now. Oh, right there. Okay, 83 degrees. Let's come back in a little bit and see what happens.
So let me get this straight. You are using a heat lamp right next to a globe and finding that the area of the globe right next to the heat lamp is warmer than the area that's facing away from the heat lamp. Colour me surprised.
How can it be that in the morning in the summertime, it's actually cooler than in the wintertime at noon? It doesn't make any sense, right?
Well, the thing is, in reality, it's not. For the angle of the sun to be the exact same in the summer in Michigan as it is in midwinter in Michigan, which is 24 degrees, then it would need to be around 8:19 a.m. in the summer for them to be the same. The average temperature in Michigan in midwinter is around 0 degrees Celsius. In the summer at around 8 a.m. it's closer to 15 degrees Celsius. But you have to take more things into account. The air pressure, the air currents, the fact that the ground has been heated during the day for a longer amount of time. It is far more complex than just a snapshot of the angle of the sun at a certain time of the day.
Okay, just for fun, let's take a look at the hottest day of the year. Okay, now we got to tip forward. And we're going to use our measuring stick again. Let's see. So you can see from Michigan, it's pretty close. Yep, it's like really close. Really close. Okay, let's look at 74.5 degrees this time. So it's a half a degree lower than last time, which isn't much. Let's get our initial reading here. Okay, we're on Michigan. It's 88 degrees. Let's come back in a few minutes.
No need, Anthony. You're using a heat lamp right next to a globe to try and replicate the sun's rays hitting Earth. It is not going to be accurate. And to top it all off, you're doing it at 3 a.m. Madness. Go to bed, buddy. Well, with Anthony safely off to bed, it's time to say we are done and dusted for another Flat Earth Friday. I really hope you enjoyed that one. What did you think of Anthony's little experiment there? I mean, at least he tried, bless him. But we're done. So thank you very much for watching. It truly is appreciated. If you enjoyed it, please do consider subscribing to the channel. And of course, if you really enjoyed it, hit that like button too. I've been Simon Dan. Have yourselves a great day, and I'll see you all tomorrow for the actual Flat Earth Friday, where we're taking a look at a Flat Earth TikToker. See you then.